webinar. My name is Pato from Global, so I'm really thrilled to welcome you all to the official launch event of our latest auto machine learning platform called NIKO. So, as a valued member of our network, we are delighted to have you join us today to celebrate this occasion. So, for this launch event, you will have the opportunity to learn more about our company a little bit, and then hear from a panel of some specialists sharing their real-world experience. And we'll also get an exclusive preview of our platform and live demonstration of its capabilities for various use cases, such as debt collection, credit scoring, insurance scoring, marketing, and so on. And we also have allocated some time for a Q&A session where we can ask your questions and learn about NIKO's capabilities. And you can also ask some questions to our panelists as well. So this is today's agenda, and we are thinking of a session of around 60 to 70 minutes for today. So thank you all for joining us for this occasion. So first of all, I would like to briefly introduce our company in case there are some people who are not familiar with Global and what we do as a company. So we are a company founded in 2017 in Singapore. We are a company founded by Mongolians. So the first business we founded or we operated was Mongolia's first fintech business, which is called Lendemen. So Lendemen is Mongolia's first digital micro-lending service. A couple of years later, we also expanded that business to the Philippines, which is called Tomo. So we also operate Mongolia's first digital ecosystem e-wallet service called Super App, as well as an e-commerce called Banana Mall. So all of these are B2C businesses of ours, utilizing our in-house built technologies such as AI and machine learning and other technologies. So for the past couple of years, we have actually partnered and got invested by some Japanese companies such as Marubeni Corporation and SBI Holdings, where we have an open alliance with them. And at the same time, we have been focusing more on our B2B fintech solution business, which we have built upon our own operational know-how over the years and our also proprietary technologies. So last year, we've also formed a technology partnership with Standard Chartered Bank, where we are developing a few of their new services and some projects with them. And we've also been busy with our digital asset exchange service in the last few months called dnode as well. But I won't go into too much detail of our operations. So the product today that we are going to launch and to introduce to you all is one of the B2B technology solutions, which is the AI and ML-based auto machine learning platform called NIKO, as you can see here. And apart from that, we also have our own custom credit scoring solution, as well as LAS, or what we call lending as a service, digital lending platform for financial institutions, as well as open innovation management platform solution for companies looking to manage their ideas, insights, and incorporate them into their own innovation process. So that is a very brief company introduction for anyone who is new to Global. Hope you have some understanding of what kind of company we are. And without further ado, I think all of you are here to learn about our new auto machine learning platform. But before that, we are honored to get insights from professionals who have experience with enterprise AI, machine learning. And so I would like to introduce our panelists for our panel discussion today, where we hope you will get a general idea of how these professionals or how companies utilize AI and machine learning for their business. So first of all, we have Mr. Yasuhisa Kato, who is the CEO and data analytics consultant at Shaw Consulting. He has 20 years of experience in data analytics and specializes in credit scoring, area analysis, CRM, among others. And then we have Mr. Ich Jahlun, or Jay, as he is known. He is a financial analyst, former engagement manager at McKinsey and Company, and has consultant background in machine learning model inclusion in the financial sector. And he is currently the CEO of Altex, crypto investment platform. So, gentlemen, thank you for accepting our invitation to speak and share about your experiences today. It is our honor and privilege to welcome you to our product launch webinar. So let me just maybe stop sharing and so that people can see your faces there. So right off the bat, I would like to ask our panelists the first question, which is, could you share with us your experience with the enterprise AI, or your experience with implementing AI in business, and where do you think or see the trend is going in this industry? So, Kato-san, if it's not a problem, could I start the first question with you?
Okay, thank you, Bato, for this opportunity and introduction of myself. Let me do a quick self-introduction of myself. As Bato-san already introduced me, I've been analysis for like 20 years, and I'm a kind of outside professional, not an in-house data scientist. So I was I'm actually now also doing the analysis for the clients, lots of clients, and like finance clients, and like manufacturers and retailers, any kind of companies. And I've been implementing models, but the decent trends, as Batson asked me, is like the AI or machine learning is, gradually the industry company is have a tendency that going to be build their model by their own. Like, it used to be outside professional work, so that they don't have to get responsibility for the function of the model. Like it's like a space skateboard, and it's really difficult. It was really difficult, but now that thanks to the the developing of the technology and like a lot of old ML tool, like NIKO also, and so that the company tends to make their own model by their own people. And my profession is also kind of shifting to the outsourcing and creating model for them, to like consulting and giving advice, since I have a lot of experience. So that's kind of the tendency that recent trends. So is that enough answer for you, Batson?
Yes, thank you, Kato-san. So you said that in the past, AI in enterprise was more in-house, but now it's shifting towards more outsourcing, right?
No, it's kind of opposite. Like it was
opposite.
Yeah, it was used to be a really outsourced matter, but it's now getting into the more inside sources, like
right. So is there any reason for this kind of changing trend in your opinion?
Well, I think it's the AI or machine learning is really get popular in these days, and there's a lot of engineer analysts that they can do it. Like if they have a doctor or like a master degree, they can use Python and and all the technologies, programming almost free, so it's very easy to access. And there's a lot of people who can actually perform the machine learnings. And also that there's a at first, like 20 years ago, and the company owner, like a executive person, doesn't familiar with these machine learning idea and how does it work and how it's good to the business. But these days, there's a lot of cases that they implemented and do a lot of good in business. So yeah, I think that's why. And also most of all, it's very expensive to outsource this, like a hire data scientist. It's very expensive. So yeah, I think that's would be a good reason. The more popular and more understanding, and they want cheaper. So that will be the reason to make it like in-house. Yeah.
Right. Thank you. I guess, outsourcing is expensive, so there's more reason to use, for example, auto machine learning, which is
Right.
much more easier to use and I guess more easier than implementing in-house, right? So, but we'll talk about that a little bit later. But
Yes.
let me hand the mic to Jay and ask the pretty much the same question, like your experience with enterprise AI, and do you see any trend where you are working from, where AI in enterprise is heading towards, in your opinion?
Sure. Yeah, maybe before I jump into the details, I can just give us quick background of myself as well, right? So I spent 4 or 5 years back in consulting. I worked for McKinsey and Company. I was in their digital practice, where I drove engagements around helping the financial institutions unlocking value of their data, right? So basically, all these banks and insurance companies, mostly financial institutions, the big advantage they have is they have tons of data sitting in their, different systems. The question is, how do we unlock it and create business value, right? And one of the tools, and quite advanced ones that are being used, all these big banks and financial institutions, are obviously, machine learning and AI-based solutions, right? So I guess to answer your question about the trends, I think overall, right, the entire, different corporations across different sectors, they usually go through different phases of their, use of data and use of, different sophisticated solutions. I mean, there are organizations that live by just generating, basic reports and insights, etc. Some of them try to build, forecasting, right? Sizing their markets, etc. And then the next level would be around, developing all this prescriptive and predictive, algorithms, etc. That's when machine learning comes in, right? And on that end, right, what I'm, at least, based on my personal experience, what I'm seeing is, first of all, if you look at Fortune 500 companies, across their strategy view, okay, like strategic directions, data and analytics is basically one of their core priorities. Because, we are living in a digital age, and COVID-19 reaffirmed it, and everyone is getting focused on, okay, how do we digitize, how do we, work on the data, and how do we create algorithms and models to use in the business. So point number one is around strategy must include vision around digital and analytics, within digital and analytics, machine learning, AI. Number two, I think bigger enterprises, most of them have done some kind of a use case successfully, partially successfully. Right now, what they are thinking or pushing towards is scaling. Okay, so basically, let's say if you are a bank, right, or non-banking financial institution, you've tested out, I know, like credit scoring, use case. The point here is you tested it, you built a model, you tested it within a certain environment. How do you scale it across your different branches? How do you scale it regionally, etc.? I think that's becoming, bigger part of the next step. Within that also, I think you and Kato, talking about the costs of it, right? I think the focus is around streamlining. Okay, how do you automate from the point of data collection through data ingestion, building the models and sending it to the final user as an output that's business sensible and can be used to make business decisions. So that's where also, main focus is around. Regarding I was just hearing about this outsourcing versus insourcing. I think, people are moving towards insourcing for sure, because the reason is obviously, it's a strategic advantage. If you wanna differentiate yourself in this, fast changing, tech-driven environment, you better build your own internal capability, especially the ones that make you, ahead of the pack, right? Maybe some of the commodity-like processes can be automated / outsourced, but your vision, your strategy, plus all your core advantages right now are sitting within the in-house COE, which is Center of Excellence or data labs.
Great, thank you for the very comprehensive answer, and I think you touched upon two really important points, like Fortune 500 bigger enterprise companies are more successful in utilizing AI and ML within their enterprises, and I think that speaks some degree to how AI and ML is actually, accessibility to AI is quite important, right? So all the big companies, big enterprises who has the resources that can employ data scientists or have those kinds of teams within their organizations have the strategic advantage to have those kinds of teams. But yeah, thank you for the answer. And I see that Stephen is here, and thank you so much, Stephen, for joining in. We have started about 20 minutes ago, but we are so glad that you could make it. I believe it's like very early in the morning for you over there, right?
Yeah, it is, but and also some technical issues, which is always the way, isn't it? So yeah, great to be joining. So thanks everyone.
Thank you. So just to give a brief introduction to all the attendees and all the other panelists about Stephen. So Stephen is a founder and venture lead at Standard Chartered Ventures, the innovation and venture building department of Standard Chartered Bank, and he's joining today from the UK. So yeah, thank you so much. And I believe Stephen is also, has a lot of experience with alternative credit scoring, DeFi, low-code model implementation in the financial sector. So we are really glad you could share your experience in developing AI models for businesses with us today. So I just asked the other panelists, Kato-san and Jay, the first question, and they have given us their answers, and I would like to ask pretty much the same question for you. So can you share with us, Stephen, your experience with the enterprise AI and your experience with implementing AI in business, and do you see where the trend is going in this regard?
Yeah, well, my perspective is quite heavily influenced. Obviously, we've been working together, sort of a client and customer relationship, but also working within the bank as well. So SE Ventures is a venture building arm where we try and build startups, but we also do it within the context of the bank itself. So we have quite a good experience here of both trying to leverage new technologies such as this, but also try and do it within the confines of fairly heavily regulated, very high compliance environments. So some of the things that I've seen and some of the trends in trying to implement these technologies are somewhat influenced by that, I would say. So one of the things that is like really top of mind is a real desire to try and improve the speed and efficiency of our existing processes and our existing capabilities. We have large teams that develop models and scorecards. They're heavily regulated. They go through many processes and many steps, but a lot of the steps can be enhanced and improved by some of these technologies. So this sort of quest for speed and efficiency is definitely one of the key trends that I'm seeing. So how we can exploit that more and more and more, and other financial institutions, not just the bank, but other clients that we're working with, are having the same ambition. The other thing is around how we compose our teams and where we compose our teams. Again, with cloud-based technologies and with the ability to automate and improve a lot of the processes. Even sort of in my past roles, data science teams have been quite geographically sort of globally spread. Even more so is now the case, because we're able to leverage these technologies, and we're able to sort of build, learn, and deploy faster, and therefore we're able to have teams more globally spread. And then the other thing which I was going to bring up, and I don't know if it's been brought up already, there is an interesting angle with financial services whereby there is a regulatory slant, whereby having the capabilities to be explainable. There is this sort of perceived risk that everything is held within a black box, and when regulators, certainly in some countries that we operate in, want to see how a decision has been made, how a score has been calculated, what are all the moving parts that sit behind some of these capabilities. And I appreciate this is very specific to financial services, but this this element of how can you then explain the results that you're finding, how can you step through each of the elements of the process, yeah, so those would be the sort of three key areas that I would sort of highlight based on my experience, mainly within the bank, but also prior to joining.
Right. Thank you, Stephen. Yeah, those are really some important points, I believe, especially the explainability part is really interesting, because when we built NIKO Auto Machine Learning platform, we really try to emphasize on the explainability part, especially the explainability for business people. So not just data scientists, right? So business people can use the platform and understand why a certain result is made out of this machine learning model, for example. So I think that's a very important point that you have touched upon. So I think that's a very nice segue to my next question, which is, in your experience with implementing AI or ML machine learning technologies to businesses, what factors do your company or other companies in general prioritize when they consider doing this? So you've touched upon explainability and the speed. Any other specific factors like cost of implementation, ease of implementation, for example? Let's start with Stephen.
Yeah, sorry. Yeah, I think cost is obviously a huge factor, but I think interestingly, what we found, the cold hard figures are sort of one thing. Making the numbers work, helping the business case work. That's usually something that can be done. You can usually, these technologies often find cost savings. One of the challenges that we've found is it's related to cost. It's about prioritization. It's about finding the right slot in the roadmap, finding the availability of resources, finding the right sign-off from various stakeholder groups. So the business case is sat there with a green tick, but there's still a bunch of other green ticks that you need to go through. And I'm talking more sort of enterprise and above type level organizations. That's been quite a common one. And then alongside that I've touched on the sort of regulatory piece around explainability, but then also part of that is the results, the performance, the output in a lot of detail. All those things seem to sort of segue into each other, but yeah, those would be the additional ones I would highlight.
Thank you. So just want to be considerate of time, and I would like to ask the same question to Jay. So any specific factors your company or your past clients consider when they implement AI for their businesses?
I guess, I want to reiterate one more, the point I just, said in my previous answer, right? So having this strategy level alignment, business buy-in, it will take you a long way, right? So because at the end of the day, in all honesty today, business needs to fund it. They need to have a full buy-in, right? To even before deciding bringing in machine learning experts, whether it's outsourced or in-house, right? So based on my experience with working with banks in Asia, Europe, Latin America, etc., usually, it takes months to bring all the people on the same page on how you want to deploy this, machine learning or build this machine learning capability, right? Second, I think it's, as Steven said, prioritization exercise. Okay, so, based on my previous experience, we do have this 2x2 matrix where basically we look at the value at stake, how much value you're going to reap off by implementing certain use case and feasibility of it. So whether it's, easily feasible or it's quite complex, use case. So ideally where you want to be is, or, where you want to start is you look at the highest value at stake and the easiest one. We call it, low hanging fruits, right? So that's where you start. And obviously, you talk about every business, even like if you look at within the sector, your pain points are different. And look, value at stake can be determined by, by dollar figures, by how much, customer satisfaction it's bringing. Those are, non-quantifiable or difficult to quantify attributes as well, right? So I guess, like that's where you start. And basically, I think Steven was saying the same thing, laying out your roadmap, right? Your roadmap should be where it's logically sequenced and where you want to make sure that you are creating assets by using machine learning. Okay, so it's not just, you do credit scoring or you do churn reduction and that's it by itself. It's more of a building out cross-cutting capabilities. So you need to look at, what are the use cases or what are the machine learning elements that you can apply across, different use cases. So long story short, those are the areas, usually looked up by, again, big corporations and those who are, deep diving into machine learning.
Great. Thank you, Jay. And finally, Kato-san, can you maybe share with us your experience as a consultant for other companies?
Yes, and Steve and Jay already told a lot about like a performance speeding and etc. But so I'll just add something and make it very quick. These days, they prioritize. Of course, it's the performance stuff and cost, speed, and profits. These are also prioritized. But these days, they tend to prioritize to transfer the knowledge. Like they want to do their own, so they like to train or educate and coach so that the inside people, like the inside stuff, can understand how the machine learning works in business, how they evaluate the model, and finally how they make their own model by themselves. Those, like a knowledge transfer, they're getting more emphasizing on this, when we work together. They just doesn't, they stop being just okay, just build by yourself, by outsider, just do it for us, and then okay, I'll get the results. That was the past, and these days they want me to teach them like that, so that they can graduate being, depending on the outsider, so that they can do by themselves. That's one of the latest priority that my clients have. That's all.
Thank you, Katrina. Yeah, I think that's also in line with what we have heard a little bit before. Trainability of AI and machine learning. I think that's pretty much the same thing as knowing the knowledge and transferring to other individuals who can also use it to do it by themselves, for example. All right, thank you, gentlemen. And for the third question, it's a rather straightforward question. So what would be some hard or soft skill challenges of implementing AI to a certain business? So obviously, companies need to have skills like data analytics, programming, etc. But any other specific skills in particular that is required in your opinion? Shall we start with maybe Jay this time?
Sure. So I guess, skills is just one factor, right? Obviously, there are many challenges when it comes to implementing AI solution to the organization. I guess, bigger question is, I think even Kato was just saying about this knowledge transfer, etc. Transferring or transforming the organization into, analytics focused DNA, right? Like organizational DNA is something that's very hard to change, right? I'll say this though, right? Strategy, building capabilities, putting all those things on a paper, it's relatively easier versus adoption and scaling, right? So that's where a lot of pain points come in, and most corporations or companies fail, right, in successfully implementing machine learning and AI solutions. If you are asking about certain skills, I would say this role called analytics translator. Some organizations call it business translator. The role most likely, sometimes overlooked, right? Because in all honesty, they don't necessarily bring either side of the skill sets, business versus analysis. These are the people basically bridging the tech team or data science team with the business team. Okay, so these are people who are responsible translating business problems into technical language and vice versa. So like imagine a data scientist or someone from tech going into the CEO's office and having this machine learning conversation, right? This can go wrong in many different ways. That's why you have this business translator who can talk to both sides of the table, right? So when coming to the C-level leadership, put it in a business language, explain the value unlocked, etc. Going back to the tech side, explaining, like more in the tech terms, like what needs to be done. I know, like, for example, like just an FYI, Carnegie Mellon, the university in the US, probably one of the best universities in delivering, machine learning and AI-based curriculum. They even like offer analytics translator trainings, right? Like for the corporate level people, given that, how important this role in terms of ensuring success of AI machine learning implementation. So if you ask me about, certain skill sets, I would say this analytics translator role is pretty much, very important. I'm not saying like you still need to have your team of data
Right.
scientists, data engineers, etc. But on top of that, that's also an important role.
Thank you very much. That's yeah, very comprehensive. And next up, maybe Stephen, can you share with us your opinion or your perspective from a bank, maybe?
Yeah,
What
sure,
sort of
sure.
skill set?
Yeah, great points from Jay there. I think putting the hard skills to one side, I probably focus a bit more on the soft skills, and I think my experience has been that the main challenge and the main skills that need to sort of be leveraged, I think, are the skills really around doing things differently, willingness to change, willingness to learn. I think a lot of the times, certainly in these kind of larger organizations, there's set processes, there's set way of doing things. Embedding new technologies like this requires a bit of an innovation mindset, a bit of a challenging mindset, and a sort of willingness to learn and try and do things, perhaps in a slightly different way. So often it's that sort of mindset, and individuals within the wider team that help embed these things to try and also teach that mindset. That's also quite important. It's more on the soft skill area rather than the hard skill area, I would say, because often the hard skills will be there. It's just a lot of the time, ways of doing things will be set in stone for quite a long period of time, and trying to change that over a short period of time can be quite challenging. So that I'd probably mention that in addition to what Jay's already mentioned.
Thank you. Yeah, so mindset is quite important, I understand. And finally, Kato-san, can you maybe share with us your experience from the perspective of, consultant when you talk with the client?
Sure. To be
Curious.
honest, most of my answer is already, told by Jay and Stephen, and especially, and I must agree with Jay, because the most challenging part is find a translator for the business to this techie and the AI machine learning. Because I've been working with a lot of like a very smart doctors, like a physicist, or like a very smart doctors that they can understand the mathematics, and they can write the like a algorithm, they can write the programs, but they don't understand what kind of models they have to build to utilize the business. And also my client is a specialist in business, so but they cannot just give it the right direction, what which kind of models they want to build. So my value is always being a translator, so that I can manage the go and to the doctors and techie part. So, and I'm talking to the like a people like I used to work with, and then they want to be a data scientist, so that they can like gain a lot of money, like earn a lot of money. So I always say that to be the translator, because just writing the code or knowing the basic of the mathematics, that will be like a common technology. So that will be in time, there's a lot of people can do it, so that the price will be like a decrease. But the business translator to this AI matter, like a machine learning problem, these value won't be never decrease. So I always keep talking to them that if they want to success in as a data scientist, try to be a translator and understand about the business. So yeah, I totally understand with Shay. Yeah, thank you.
Great, thank you, Kato-san and Stephen and Jay. So I'm sure our attendees would like to know more about our panelists' experience and knowledge about this topic, but unfortunately, I see that we have already been going on for 40 minutes, so we don't have a lot of time left. So we will have a small Q&A session at the end. So if there's anything our attendees would like to ask our panelists, please feel free to leave your questions on the Zoom webinar. And Thank you so much to Kato-san, Steven-san, and Jay-san for their valuable input and discussion for our topic today. And we will have Sarah's introduction of our NIKO machine learning platform. So if you have time, please, have a listen to Sarah's introduction. So without further ado, I would like to hand the floor to Sarah, and let me just share my screen. Okay. Right. So Sarah is a lead data scientist at Ant Global, and she's also the product lead of NIKO Auto Machine Learning Platform. And she's also a former data science manager at Accenture Japan. So Sarah, the floor is yours.
Okay, thank you, Bato. Hi, everyone. So since we don't have much time, I'll just go with it. Let me share my screen. Okay, so today I'm really excited to share you guys what my team has been working for last half in the year. So as Bato has mentioned, NIKO is a no-code AutoML platform where you can build your own machine learning model without writing a single line of code, so you don't have to do the programming. Before starting what NIKO can do, let me share a small story behind why we wanted to build this solution. So as some of you might already know, on Solutions, we are mainly build solutions and technologies on the financial industry, but NIKO is not limited to the finance or fintech use cases. It's a use case agnostic solution. So there are two reasons that we wanted to build the solution. So our team, we have around 10 data scientists and machine learning engineers working on the fintech AI-based solutions. So we started building NIKO partly because we wanted to keep our job, that data scientist job, more fun. So naturally, I think there are many data scientists joining today, so they would probably agree with me. So naturally, data scientists, we want to try new things every time. So we don't want to stick with one model. So we want to try new use cases every day. But once you build a machine learning or AI model, and that's being started used in the business, there we have limited time to try new things, right? So, but actually the tasks that needs to be done in the operation or the model maintenance parts, they can be done anyone if we can delegate it correctly, or tools like NIKO can save some time so that we can focus on a more fun part of our job. And then second reason is because also we wanted to try new things, but we don't have time. But while working in the enterprise AI field in last 6 or 7 years, what we concluded is like, if we can make the customers, the business users understand the essence of the AI model, they can actually build their own model by themselves and then use it by themselves. So we wanted to build such a solution so that the business side users, they can actually build their own AI model without depending on anyone like data scientists and everything. So that as a society, we can benefit from AI technology. So that's the reason we started building the solution. So in NIKO, what you can do is you can access in the web interface and then start building your model. All you have to do is prepare your data and then upload it to the solution. And also, as our panelist mentioned, when we start using AI in business, there needs to be business translators, right? So up until now, data scientists try to do the translation part, so they have a lot of things to do. But what NIKO is aiming is making the business side user, like the credit analyst or the marketing specialist, we want them to use NIKO to build their own AI solutions. So what we're trying to do here is we want to make the machine learning model building steps simple as possible, and then modeling results as explainable and easy to understand as possible. And once you build the model, you want to use it on your business, right? So in order to do that system integration, the model needs to be integrated with your system. And then for this task, for example, you need different capabilities like ML engineering. But in NIKO, we have open API offering so that you can easily integrate your system with NIKO so that you can use the modeling results. And then fourth capability is in the machine learning field, it's important to monitor your model because the model will learn from the data. So every day there will be new data, and then the world is changing. So depending on the if it takes some time, the model will get old. So you have to keep it updated and then retrain everything. Okay, so we are building NIKO to be able to do all these things. And then today I'm just going to share you the first version of NIKO, and then it will be keep evolving in the future. Okay, so as I mentioned, NIKO is use case agnostic. So which means NIKO has a modeling engine. So whatever data you can feed to NIKO, you will get your model. So it's not limited by certain use case. All you have to do is prepare a tabular data, structured data of your business, and then you can upload those data and then get your model. So which means right now it doesn't work on the image or the text, unstructured data like image and the text. So here are some examples of the use cases we can think of, but I think business users, they can actually think of what they need for themselves. Okay, and then next one is who should use NIKO. So obviously you need to have your data. So NIKO is for the companies who already have historical data of their business, data of their customers or their data of their sales, the kind of data you need to have. And then also for the companies who want to make their data scientists' life easier. So as I mentioned, we have a lot of things to do. So in order to prioritize the most important tasks and then focus on the most valuable tasks, you can use NIKO to save time for example, to save your programming time. And then also NIKO is for companies who doesn't have the data science or the machine learning engineering capabilities yet. So in the end, we are aiming to build solution that the business side users can use. So if you want to try AI, even though you don't have data scientists, you can try NIKO as well. And then as Steven mentioned, it's the will to change, will to evolve. So it's for the companies who want to try AI and then empower their business using AI solutions. And then lastly, NIKO is for the companies who is not familiar with AI, but they want to try, right? So as our panelists mentioned, when you try to implement AI to your business, there are many things you have to think, right? You have to think about the business value and then maybe ROI, and then you have to think about data scientists, and then maybe the management, they have no idea how to prepare the environment for the data science. So there are many things to think, so which is making it difficult for companies to try AI. So NIKO cannot solve everything, but we are aiming to solve part of the problem so that the companies can save some time and resource of the data scientists, and then try AI in easy way, and then actually finally achieve AI-powered business value. Okay, so what NIKO can do, this is the basic flow of the machine learning model. So in order to build machine learning or so-called AI model, you have to prepare your data and then do some modeling experimentations, try different things, and then evaluate those models. And once you decide, okay, the model is good enough to go for the business, you have to think about some rules of how to use these models in your business. And once it gets done, you can start scoring new users, or they start producing predictions. And after the model is launched to the production, you have to also keep an eye on how it's performing. So as I mentioned, the model can get old because the data is old, so you have to keep monitoring and then retrain the model if necessary. So in NIKO, all you have to do is prepare your data on your system and then upload it to the NIKO, and then you can build your own machine learning model, do the prediction, and then also monitor the performance. Okay. So as of today, these are the features that NIKO have. So from now on, I will show you some demo and then explain some use cases about how to use NIKO. Okay, so I think we mentioned 4 use cases in our announcement: credit scoring, debt collection scoring, marketing, and insurance scoring. So as I mentioned, the solution is not limited to those use cases, but these are the ones we can explain to you guys. So I'll start with the use case 1. This is about the credit scoring. So in this use case, we are going to cover the binary classification modeling and modeling report, how to choose the best performing model, and then how to set your thresholds, define your business rules, and then how to use the prediction. So these features will be covered in the first use case. Okay, so in our use cases, we are using the open data, so it's not the actual business data, but I think it's enough to explain you guys the capabilities of NIKO. So in the first case, company profile is like this. So let's assume there is a non-banking financial institution operating in a Southeast Asian country, and this NBFI's main loan product is micro cash loan, small amount cash loan for the wide sector of the customers. And this company has around 30 employees, so it's not that big company. So they have some problems with their credit scoring process, because what's happening is here, they're more than 50 days overdue rate, repayment rate is quite high, it's 30.4%. So, and then they would like to decrease this overdue rate. And currently they are using some simple scorecard, and then since it's a small company, they cannot afford to hire professional data scientists. Okay, so that's the problem of the company, and currently they have data of around 2,000 customers in their system, which contains the customer profile, mobile device info that is collected when they're applying the loan, and then also a loan repayment result about how they actually repaid their loan. So I will explain the details later, but the result is like they built an AI model in NIKO, and then using this model, they are actually able to detect the high-risk customers. As a result, they can decrease their overdue rate down to 5.8%. So it's from 13.4% to 5.8%, while keeping the around 80% of the customers. Okay. So, okay, so I will show you how to build model on NIKO for this case. So we are going with the credit scoring. This case, sorry. So just to keep some of our demo process simpler, I already built 2 models using the customers' data of this company. So first model is, it has a sample of 1,400 customer. So assume the company decided to use the first 1,400 samples because they thought it's better. And then the accuracy result was quite good. And then we can see all the metrics, but the company didn't satisfy here. So they tried to something different. And the next, what what they did was increasing the samples of the model. So they increased the sample to 2,200 samples and then tried the same model. And now I'm going to try the third model, where what I'm doing is based on my domain knowledge of credit analyst, I'm adding more data fields or tweaking some of the data fields to make it more like the reflect my business or the domain expert knowledge on this one. Okay, so for this one, we are trying the binary classification. So binary classification basically detects whether the customer will repay their loan or not. So it has two options to predict. So as you see, when I insert the same name, the platform will automatically detect the version of my model. So this is the third version of the same model. And then I will upload my data. So you can upload a CSV file here. So once the file is uploaded, we can see what's inside. So we are going to build a model using this data. All the data fields are visible. So first, what I have to do is I have to choose the target value of the model, which is over 15 days flag. So if the flag is 1, which means the customer overdue, okay? And we have the customer's email, demographic information, educational information, and then also some financial information like what's their income, everything, and also have some mobile data. Okay, so I'm going to build a model using this one. So once I upload my data to the platform, in order to make it easier to use for the business users, we have these suggestions to the user. So the data I uploaded, the NIKO can evaluate the data quality. So since it's saying it's good, I'll just proceed with the modeling, and then some of the modeling parameters I can choose, but I'll just go with the default one. So now the modeling process starts. So what it's doing is it's running 5 different binary classification algorithm, and then choosing the best performing one. So how it's choosing all the details is already included in the technical document in the platform. So now it's done. So it already ran the 5 model and then get the best result of the best performing one. So our accuracy is 0.91, and then the model selected as the best performing was the light GBM. I think some of you are already familiar with this one. So the results are already shown. So the first one is to make the results more easy to understand for the business users. We have the feature importance. So this part literally telling us what kind of customers' characteristics or customer information contributes more to the modeling performance. So obviously net income. For the credit scoring case, this is very important. So net income contributes highest to the model. And then we have the cell phone, model name, loan amount, and then some location-based characteristics, industry, age, income source. So for all of the features, we can get the feature importance. So once the business side user look at this one, and then if they think it makes sense, it fits their domain knowledge, it might be easier for them to use the model, right? And then we have all the machine learning modeling metrics here. So, and we have also the tips in here, so that even the people who doesn't have much knowledge about those metrics and everything, we give them some hints and tips on how to use those ones. Okay, so now I built 3 models, and then I need to decide one model to keep doing the scoring. So what I can do is look at everything in one screen. So I'll choose the previous 2 versions of the model, and then I'll compare them. Okay, so Here is the result of 3 models. According to the accuracy, version 3.0 is better than the other 2. And then we can see the important features as well, and then distributions of that one. And also we can see basic evaluation metrics here. So lucky that our model is so good. Every version is a good model, but here's the great model. So we can see different calculations of the metrics. For example, how good the model is detecting the overdue customers here. And personally, I will just look at the ROC AUC curve, and our version 3.0 is good. So I'll just choose this one as the best model, and then going to use this for the prediction. Okay, so in order to do the prediction, I have to deploy this model here. Okay. Oh, sorry, I forgot one step. So I choose this model as the best performing one, right? So now what I have to do is I have to set the threshold to decide when we should consider this person as the high risk, and then when we should consider this person as the low risk. In other words, when we are going to approve them, and when are we going to reject them? Okay. So as for the single threshold, we can set it here. So we also have the scoring distributions available here. So looking at those informations, we can see like how well the model is detecting good or bad customers. So since the scoring range is between 0 to 0.3, it looks quite good. So I'll just decide, I'll set the threshold at 0.3. So if the customer has the score more than 0.3, they will consider it as high risk. And then if it's not, they will consider it as low risk. And maybe it's too harsh. Okay, I'll just go with 0.5. And okay, so what I can do also is I can add tags to the scoring results so that it's easier for the businesses to use. Okay, so for example, what I can do is, okay, we will just accept everyone between this score range as good customers. Okay, how about this one? And sorry, I'll add the next range. So reject. So I can design tags like this so that it might be easier for the business sites to use. So as you see, if we approve everyone below the score 0.5, the overdue rate is 5.8%. So that's what I showed on the slide here. So if we just focus on these customers, we will still get the better overdue rate compared to the previous current situation where we are not using the scoring model. Okay. So, and then next we will go to the prediction. So as for the prediction part, we have 3 options. You can just type information of the certain customer here and then see the prediction results. So for this data, it's too many fields. So what I will just do is I will upload a list of the customers and then see the prediction results. Okay, so this is the result. What we have is the customer's score result. And then based on, we decided the threshold as 0.49. So if the score is less than 0.9, we will take this customer's good customer that is labeled as 0. And if it's more than that, we will consider this as high risk customer that's labeled as 1. Also, we have the tags we just defined here. So based on the scoring result, we can design auto approve or reject. So in this way, it might be easier for the business users to use the result. So in the actual business cases, since you have already loan system, you would like to integrate this prediction part to your system. So for that one, we have API integration available. So just looking at these documents and everything, your development IT member should be able to integrate NIKO with your system. Okay, so that was the first use case here. As I mentioned, the over the rate was 13% before the NIKO, and then if this client can use NIKO to detect the high-risk customers, they can decrease the over the rate to 5.8%. Okay, I'll proceed to the next use case. So this one is about marketing, and then I'm going to cover some of the features. The model would be binary classification, and then it would do some prediction, do some backtesting, pre-training of the model. So this one will focus more on how to do the monitoring on the NIKO. Okay, so the fake company here is a retail company, and they would like to decide whom to target for their upcoming marketing campaign or the discount campaign. And then, of course, they would like to achieve higher conversion rate. So they want to choose the target segment really carefully. And if looking at the data, if they randomly approach customers, so if they just select the random customers to as the target, their conversion rate would be 14.7%. And also, it's difficult for them to hire the data professional right now. And they have quite a large amount of data. They have historical data of the 62,000 customers, which has the engagement history, previous discount history, and then conversion rate of the campaign. So basically they have the data of what was the characteristics of the user when they offered the campaign previously, and then what was the campaign result. And then, by using the NIKO, if you use the NIKO to create the machine learning model to optimize the campaign targeting, they can actually double the conversion rate. Okay. So I will go here. So since you guys already know how we build the model, I'll just use the existing model. So for this marketing optimization, we already built the model. It has total 62,000 record, and then we took the 30% of the data to validate the results. So now we are showing you the result, how the model performed for this 30%. Okay, and this data set has few features. So it's about whether the customer used buy one get one offer, and whether the offer matched the customer's needs, whether they used discount before, how long they are with us, what kind of channel they prefer. Those kind of information is here. And then current model looks like this. It's a bit worse than the previous credit scoring model, but depending on how we are going to use it, it can be used in the business. So I already set some thresholds. So I'm going to target the customers whose score is more than 0 to 5. And I also added some tags here. So what the client is going to do here is they have two channels for the campaign. So what they can send email, or that they can do, they can call every customer, or they just decide not to reach to the customer. So based on the scoring range, I decided these tags. So for the score range between 0 to 0.17, since the conversion rate is around 10%, we will not approach to this segment. And the next one is between 0.17 to 0.25. So for these customers, the conversion rate is 20%. That's 1 in 5 customers. So we will just use email, which is less costly channel. And then other customers, we will try to call, because 1 in 3 customers might want the product. So we can do this kind of tagging here. And this model is already deployed. So now we are going to go to the future. So we are using this model, and then we already do the scoring for the new 1,000 customers to choose as the campaign. Okay. So what we are going to do now is we're going to check whether this model worked well with the new data that they do the scoring. So we built the model, and then after that we scored 1,000 customers, and then go forward 1 month, and then now we know how they reacted to the campaign. Okay, so we can know whether they actually bought the product or not. So based on those information, we are going to monitor the modeling performance over time. Okay, so in order to do that, we have simple backtesting feature where you have to upload the ground truth of the data. So we already do the scoring. Now what we have to do is upload whether this customer actually bought the offer, actually accepted the campaign and then bought the product. Okay, file where you can upload customer ID and then ground truth. Ground truth means whether they conversed or not, and then we can do the backtesting. So in the backtesting, we are comparing the initial model result with how this model performed on the new 1,000 customer. So we can compare all the metrics here, and if the backtesting result is worse than the model, which means the model is getting old. So for that case, maybe we want to update the model by uploading new data. So we can see all the metrics. Actually, for this case, it looks good. But if it doesn't look good, and then if you want to update the model, or if you assuming like the customer behavior changed completely, so you want to create a different version of the model, you can build a drift version here. This is basically retraining. So all the model names and then versions are automatically set here. And now I'm going to build model based on this 1,000 customers result, and not sure whether we have enough time. Okay, so let me build the model here, and once you get the new draft version, that's the new updated model, we can compare it with the previous version and then decide whether we will keep using the old model or going to change to the new model. So I'll just use the compare again. So they have same experiment version, but the drift version is different. And this one is the drift version. So if you just look at the accuracy, it looks good, but machine learning is not about accuracy. So if you look at the more other metrics like the ROC AUC, actually this one gets worse. This graph, it needs to be closer to 1, but it's around here. So which means our new trained model is not performing good enough to beat this one. So I'll just end the comparison here and then keep using the old model. Okay. And so next 2 use cases. Okay, so for next 2 use cases, what we are going to try is we have one binary model, and then also we are going to try multi-classification model and do the business rules and prediction. So I'll try to go quickly. So use case number 3, it should be 3, is the debt collection scoring. So let's assume same non-banking financial institution of the use case 1, who is operating in Southeast Asia, and they have 30 employees, right? So the problem here is, sorry, most of their employees are working on the debt collection part, and it's taking a lot of time and resource and then manual work. So they would like to optimize this part of the process. And particularly, they want to know who's going to be overdue less than 15 days. And we can just let them be there. They will repay their loan in 15 days anyway. And then we want to know who's going to overdue more than 15 days. And then as for the collection, they have data of around 5,000 customers information. And I'll show you the results later, but the actual result was like this. So when we use the multi-classification model, they are able to know who's going to be overdue less than 15 days. So which is making it possible for the business to focus more on the high-risk customer that is more than 15 days overdue, so that they can optimize their process. So for this one, I'll just use multi-classification. Okay, so this is the first version of the model, and I'm going to use data from here. So in this case, we're going to use this column called debt collection group as the target value. It has 3 values, less than 15 on time and then more than 15 days overdue. So I'm going to use this one, and we will not use this feature in our model. We will just deselect them and then upload the files. So the process is basically same for the multi-classification as well, but we are just using the algorithm that is more suitable for the multi-class classification. Okay, and then report looks same. As for the multi-class classification, you can see the results of each class. So you can choose the class of everything and then see them at once, or like this. So if we have a look at the ROC curve on this class, which is less than 15 days, detecting this class, it has a better performance than other two, which means this model is able to detect the customers who are overdue less than 15 days. So if we do the scoring using this model, we can know who's going to be late less than 15 days, and then we can just deprioritize them and then focus more on more than 15 days customers. So that's how we can use it for the actual business case. Since I don't have much time, I'll just go to the next use case. So this one is about insurance scoring. And here we are assuming a car insurance company, and they would like to predict and control their loss ratio, which means they would like to know who's going to claim, who's going to request for a claim beforehand. And their problem is, okay, they have data and then they want to categorize their customers into high risk of claim or the no claim, but they don't know where to start, and they want to try AI, but they don't know where to start. And for this company, they have the customer data of around 9,900, which contains the customer's profile, vehicle info, and then flag of claim or no claim. Okay, so I also already built this model on NIKO so that we can just look at the results here, car insurance. So the modeling performance looks good. This one is binary classification because we only have to know whether the customer is claimed or no claimed, right? And the model chosen is like GBM. So as we look at the important features. Postal code, which is the location information of the customer, was important. Annual mileage, gender, vehicle year. So, and also they used credit score from the bureau for the model. So these are the important variables. So assuming I am an insurance expert, these features looks good. So I'll just go with the metrics, and then AUC is close to 1. So this model is working well. So what this insurance company can do right now is, okay, they can use this model and then implement scoring to their business. But for this company's case, they are just want to try AI and then understand the risk of the customer, right? So if we have a look at this score distribution, we can know what is the distribution of each score range, and then what's the possibility that these customers in a certain score range would claim. So as you see, when the score gets higher, the claim ratio is increasing. So they can actually analyze their portfolio here. So they can know, like, okay, what % of the customers is high risk compared to the other ones. They can do those kind of analysis, and then based on these results, they can discuss this one in the management, for example, and then decide what to do next. So what they can do is, like, they take some actions to mitigate those risks, or they decide to use this model in their actual business process, and then maybe increase the claim amount of high-risk customers, or maybe just reject some of the customers. So those kind of actions they can take. So for this case, just using the model, you can analyze your existing customers' data, and then based on those, you can get some insights, or think about what kind of actions should be taken. So it's not all about building model and then deploying and then using the scoring. AI or machine learning can be used as the analysis purpose as well. Okay, so I think I took too much time. This is all for the NIKO's demo and then use case explanation. If you have other questions, you can ask us. So I'll just give the mic back to Batul.
Thank you, Sarah. Yeah, and I think we have one question outstanding on the QA. Someone asked, is there a limitation on how much data I can upload to NIKO? Can you maybe answer that here?
Yes, right now we have some limitations on the file size. So that is 300 megabyte. So here, yeah. So we have some requirements in the file upload here. So some of them are just a recommendation, but as for the file size, we have file size limitations, but 300 megabyte might contain 2 million rows. So it really depends on the number of rows and columns.
Right. So 2 million rows of data is usually more than enough for any businesses, basically. So you don't really have to worry too much about the
Yes.
data size. Okay. Is there any other questions from the attendees? Well, I understand we've been going on for quite some time now. So, if you have any other questions, feel free to just, reach out to us from our website or from the email that we have sent you. And yeah, so thank you all. And I would like to thank our panelists for joining in and sharing their experience and insights with us. Thank you so much to Kato-san, Stephen, and Jay.
I think there's one question. Sorry.
Oh, great. Okay.
Okay, I'll just answer it by typing. Sorry.
Okay,
sorry for interrupting.
Thank you, Sarah. Sarah is going to answer your question on the Q&A interface. And yeah, And also, I would like to thank all the people who attended the event from around the world. I'm so happy to see that most of the people actually stayed until the end. So thank you so much. And we will post the video online after a few days. So if you have missed the beginning, or if you want to recheck some of the live demonstrations, you can check back again. And again, if you have any questions or comments, or if you're interested in auto machine learning platform, we are here to answer your questions. So we also offer free trial for NIKO as well. So feel free to reach out to us, and thank you all so very much. And I would like to end the webinar here. And thank you, Sarah, as well.
Thank you very much.
All right. Thank you.